Welcome to lesson 2.7. We're going to look at polynomial and rational inequalities. So the objectives for today, we're going to solve polynomial inequalities, then we're going to solve rational inequalities, and then we'll look at some questions in context. A polynomial inequality is any inequality that can be put into one of the forms where you have a function either less than, greater than, less than or equal to, or greater than or equal to 0. So first step is going to be to set it equal to 0. Then you're going to solve the equation f of x equals 0. And the real solutions are the boundary points. Oops, sorry. You're going to locate these points on a boundary line, look at the boundary points on a number line, and then you're going to basically be cutting the number line into intervals. Then you're going to pick a test point within each interval and figure out if it's positive or negative. So then once you have a test point inside the interval, then you're going to assume everything in that interval is either positive or negative, and it flips during, at the boundary point. Then you're going to write the solution set in interval notation. So the procedure, if it's or equal to, so if it's less than or equal to, it's the same. It just means that you're including the boundary point if it's or equal to, and you're not including the boundary point if it's not. All right, so first example is we're going to solve a polynomial inequality. So if you start off with x squared minus x is greater than 20, we need to first express that, set it equal to 0, or set it unequal to 0. So we're going to subtract 20 from both sides, and you end up with x squared minus x minus 20 is greater than 0. Step 2 is then just take the equation, like set it equal to 0, and figure out what are the boundary points. So x squared minus x minus 20, so that equals 0. You can factor it in x minus 5 times x plus 4, and you end up with x equals 5 and x equals negative 4. So negative 4 and 5 are your boundary points. All right. So you have a number line, you got negative 4, and you got positive 5. So you have 3 intervals. You have everything before negative 4, everything between negative 4 and 5, and then everything to the right of 5. Remember, we're going to choose one test point within each interval. So for everything to the left of negative 4, we're going to pick a test value of negative 5. We're going to substitute negative 5 into the expression x squared minus x minus 20. What you end up with is positive 10. So the conclusion is all the y values in that interval are going to be positive. For the interval between negative 4 and 5, pick 0, substitute 0 in, you get negative 20. Since it's negative, we're going to assume all y values in that interval are negative. And then for the interval, for everything to the right of 5, we pick 6. Again, you can pick anything you want as long as it's more than 5. For the interval between negative 4 and 5, you can pick anything you want as long as it's between negative 4 and 5, and so on. So in this case, we pick 6. Substitute 6 in, you got a positive. So that means it's assumed to be positive for all. So what you have here is a solution set. So based on step 4, it's positive left of negative 4, right of 5, and it's negative in between. So the solution set, since this is where it's positive, like the original inequality was greater than, then it's greater than, again, for the interval to the left of -4 and to the right of 5. So if we were to shade the part of the graph that actually is a solution, to be, again, left of -4, right of 5. Um, all right, so second part of the objective. We're going to do the same, but for a rational inequality. So that just means it's a rational function as opposed to just any old polynomial, all right? Same exact process, it's just going to be a little more complicated. So here's your example. 2x over x plus 1 is greater than or equal to 1. So the first thing we need to do is set it equal to 0. So we're going to subtract 1 to the other side. That's what you're seeing here. Then in order to combine those two expressions, you need a common denominator of x plus 1. Now you have it over the same common denominator, simplifying it, and you end up with x minus 1 over x plus 1 is greater than or equal to 0. All right, so then those two inequalities are equivalent to each other, so we can use the one that's set equal to 0. All right, so step 2 is set the numerator and the denominator of f equal to 0. So we're going to go through a lot of the steps that we did when we were graphing rational functions, now that we're graphing a rational inequality. So we're going to set the numerator and the denominator equal to 0. When you set the numerator equal to 0, you get x equals 1. When you set the denominator equal to 0, you get x equals -1. These are going to be your two boundary points. So on a number line, you got a boundary point at -1, you got a boundary point at +1. So your three intervals are everything left of -1, everything between -1 and 1, and then everything greater than 1. If you look at the order, like the intervals there, notice how essentially we're not counting -1 and we are counting 1. Why is that? Okay, so we're not counting -1 because -1 is a number that would make the denominator 0. And obviously you can't divide by 0. +1 is okay, and that would have made the numerator 0 in the new version of the inequality. And that's okay, but that's only because the inequality is greater than or equal to. If that was just greater than, then this would also be parentheses, okay? But it doesn't matter that that's the inequality that we're working with in the inequality symbol that we're working with when we're talking about the denominator. The denominator can't, ever be 0. All right, so now again, we've got the three intervals. Test value chosen for the first interval is -2. So we substitute -2 into the function, we get +3. So then it is positive. The interval for in between -1 and 1 is 0. And when you substitute that in, you end up with -1. So the conclusion is that everything is negative. And then the third interval, everything to the right of 1, we pick the test value of 2, substitute it in, you do get a positive 1/3. It's positive, so the whole thing is positive. Let me also point out, and you saw this in the last example as well, as the intervals, as you alternate intervals, um, the sign should alternate, right? Like, so if one interval is positive, the next one's going to be negative, and then the next one's going to be positive, and it's always going to flip. If you find that you get two positives in a row or two negatives in a row, then something went wrong. All right, so then step 5 is write the solution set. So your two intervals where it is greater than or equal to is the first interval and the third interval. Then you can also write it in that form as well. And if you're talking about a number line, then we're shading to the left, on the left side and the right side, and then the part in the middle is what's not shaded. Okay, the third part of the objective is now adding some context to this. So the position function for a free-falling object near Earth's surface. All right, so an object that is falling or vertically projected into the air has its height above the ground, s of t in feet given by that function. S of t is equal to negative 16t squared plus v sub 0 t plus s sub 0, where v sub 0 is the original velocity or the initial velocity of the object in feet per second. T is the time that the object is in motion in seconds, and s sub 0 is the original height of the object in feet. All right, so in which interval will the object be more than 64 feet above the ground? So if that's the expression, if s of t is equal to that expression, we're going to say that the expression needs to be greater than 64. We want to know when will the height of the object be 64 feet off the ground. So we're going to say that expression is greater than 64 and then solve. Remember, our first step is to get everything to one side. So we're going to subtract 64 from both sides, and you end up with that expression now greater than 0. First thing I would do is, well, now you're going to try to solve, set that equal to 0 and solve. So the first thing you can do is divide a negative 16 out of each term. Then you can factor what's left over into t minus 1 and t minus 4. So your two values of t are 1 and 4. So essentially what you found out is that the rocket is exactly 64 feet above the ground at 1 second and 4 seconds. So your three intervals are everything left of 1 second. And we're starting at 0 because obviously we're not going back in time. So we're only using positive values for x here. The second interval is between 1 and 4, and the third interval is everything to the right of 4. And then on a number line, there you go, 1 and 4. So if you think about it, though, this parabola is negative, so it's going to be upside down, right? So where it's going to be greater than, my expectation is everywhere between 1 and 4, right? And that kind of makes sense. Like the rocket goes up, and then it comes down. So at exactly 1 second and at exactly 4 seconds, it's going to be at 64 feet. So where it's higher would be everywhere in between. So that's my expectation. Let's kind of work the rest of it out. So again, we have the three intervals, and we choose test points in between, right? Um, and when we find test points in between, you do find that, well, test points for each interval, you find that the inequality is true between 1 and 4. So that means the object will be more than 64 feet above the ground between 1 second and 4 seconds. All right, and that's it. So at this point, we're going to start the 2-7 practice, and we'll have time to work on that today and tomorrow as well. And we'll try to get this done before break. Let me know if you have any questions, whether you have questions on the notes or whether you start the practice and you have questions there. Just let me know. And again, this is the last lesson of the chapter that we're going to do, and the last lesson that we're going to do before break. So get to it. Let me know if you have any questions.